Hey guys, student handout number 2, experimental and theoretical probability. Let's go. All right, here we go. Experimental probability, what is it? It is the ratio of the numbers of times an event occurs in the total number of trials. So this is basically what actually happens, what does happen. Okay, like you do it and this is what happened. That's experimental. We did it, we experimented, this is what happens. Theoretical is the probability of an event happening based on the possible outcome. So basically this is what should happen. But as we know, what should happen never really happens. All right. We're going to use this spinner to answer the questions below, okay? And I have a spinner we're actually going to spin here in a minute. What is the theoretical probability? So what is, in theory, what should happen if we wanted to spin a section with stripes? So how many sections with stripes are there? I see one. How many total sections are there? Okay. I see 1, 2, 3, 4, 5, 6, 7, 8. So what are the chances of spinning that green one right there? 1 out of 8. Okay. The next question says, what is the theoretical probability of spinning a section with stars? All right, so here's the stars. There's still 8 total. Well, how many out of 8 now? 2 out of 8, which simplifies into 1/4. All right, and this last one says, what is the theoretical probability of not, keyword there, guys, not spinning a solid or striped? What is the probability of not spinning a solid or a striped? All right, so how many solids do we have? Solid, 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 solid. It's blank, it's solid. And then it says solid or striped. So what is the odds of spinning one of what's left? Well, how many are there? 3, oops, my bad. 3 out of, how many total were there? 8. So the odds of spinning something that's not highlighted in green are 3/8. All right. White dots, stars. All right, so let me change some of my names. These are called, circles are called dots. Called them the wrong thing. And the nothing is called white. All right. So let's spin and see what we get. We'll spin it 8 times. All right, so draw a tally mark for dots. What is a tally mark? So let's go back over here to dots, which I'm not going to do this every time, and just put a tally mark, okay? Not going to do that every time. You can see the numbers over here to the right where it says dots. It has a green +1. I'll let them count over there. Spin number 2 is the solid white. Spin number 3, solid white. Spin number 4, stripes. Spin number 5, dots. See, right there, we can already say, because theoretically, dots should only have been 1 out of 8, but it's already been twice. How many times have I got 2 more. Last spin. All right, so I had white blank ones with 3. So let's go back over here. White blank ones were 3. Okay. Stripes were 1 for stripes. Oops. Stars were 2, and dots were 2. All right, total number of spins was 8, 8, 8. So the stripes ended up being 1 out of 8. The whites ended up being 3 out of 8. Dots were 2 out of 8, which is 1/4. And so were the stars. All right. So did everything turn out like it was supposed to? The stripes, 1 out of 8, that was correct. That's exactly what happened. We got lucky. White should have been 4 out of 8. It should have been 1/2, but it was less, so it was less. Dots should have been 1 out of 8, but it was actually 1 out of 4, which means it was more. And the stars were what they were supposed to be. So we landed on white 1 more time than we should have, or 1 less, and we landed on dots 1 more. That is why it is called random probability. All right, are there any results in which the theoretical and experimental probability are the same? We just talked about that. I need you to put that in your own words. Yes, stars and stripes. That's because we live in America, duh. And white and dots did not match. And explain that. Put that in your own words. So stars and stripes matched. Their theoretical probability white was 1 less than the theoretical, and dots was one more than the theoretical. All right, you should have put that in your own words, but if you're still lost, stars and stripes match their theoretical probability. White was one less than its theoretical, and dots was one more. Well, hold up, Coach. Dots is 1/4. It was supposed to be 1/8. How's that one more? Because 1/4 is 2/8. 2/8 is one more than 1/8. Da, 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 da. All right, to the back we go. To the back, to the back, to the back, back, back. We go. All right, relative frequency. Relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. As the number of trials increases, the relative frequency of an event will approach the theoretical probability. So the fewer times you do it, the more it may be off. The more you do it, the more it will come close to the theoretical probability. Okay? The spinner at the right spun 50 times, and the results are shown in the table below. Complete the experiment below. All right, results. They spun it 50 times. They've already done that. Okay? And it landed on there 12 times. So 12 out of 50. That actually simplifies, guys, into 6/25. All right? The next one, it landed on there 8 out of 50 times. Okay? That should have simplified into 4/25. The next one was 13/50. That don't simplify. The next one was 10/50, which does simplify. And the last one was 7/50, which does not simplify. That is the relative frequency of their spin. They spun 50 times. They've already done that. Okay? Now, here's what I want you to do. You and a partner, let's do partners of 4. So the people sitting in your little square there. Do not move seats. Partners of 4. If there's only 3 of you, then it's just 3 of you. Okay, pods of 4. I want you to go to pickerwheel.com, PICKER wheel.com on your Chromebook. Okay, let's just do that. Pay attention. Do not start on your Chromebook yet. When you get there, this is what you're going to see. Okay? I want you over here where it says input. I want you to input each one of those numbers, 1 through 5. 1, 2, 3, 4, 5. So yours should look just like that when you're done. Okay? And all you have to do is click spin. Press count. Okay? I want you to do that 100 times and tell me your results. All right. Also, when you get done, you are going to answer number 3. Okay? Now, before you go, let's answer what we can answer at the bottom. And then I'm going to let you answer 5, 6, and 3. Okay? So here's what you're doing in just a second. Do not start yet. You're going to go. The website was Picker Wheel. You're going to do this, that, and that. Okay? All right. When you're done, bring it to me and show me. But first, let's answer number 4. What is the theoretical probability of spinning each of the numbers? There are 5 numbers. So what is the odds of spinning each one? 1 out of 5. Because each one of them's on there one time. What is 1 out of 5 as a percent? I don't know, Coach. Well, divide in your calculator 1 divided by 5. It's going to give you 0.2, which is what percent? That is 20%. So each one of them has a chance, 20% chance. All right, let's talk about number 5. How does the relative frequency change between when the spinner is spun 50 versus 100 times? You're going to have to tell me how it changed because I don't have the numbers yet. You're going to do that, okay? On number 6, suppose the spinner is spun 1,000 times. Predict the relative frequency of each spin. What should it be if we spin it 1,000 times? Okay? Because we're predicting. So we don't know it. It's not experimental. We're predicting. It's theoretical at that point. Okay? So what should it be? The same as the theoretical. It's what it should be. Okay? So it should be 1/5. 20%. Well, I told you was going to answer number 6, but I'll go ahead and answer it. All right. So let's recap one more time. Pickerwheel.com. I'll leave it right here. I'll write it right here. Pickerwheel.com. You're going to fill in the rest of that chart by spinning 100 times. Then you're going to answer number 3 and 5. When you're done, bring it to me. Ready, set, go.